Well, good evening, everybody. Round number two of the roundtable this evening. We had George Netanyahu on before, giving his presentation about gas pressure. And this evening, right now, we have RightThe Hand with roundtable 20. The lie is 14.7 PSI. RightThe Hand, are you there?
I am.
Good stuff, good stuff. Um, so you've done a video. You put it up onto your channel before.
Yeah, I did I would say I did like 3 or 4 videos and then kind of culminated all the ideas and points into this one.
Okie dokie. Well, if it's all right with you, if you can pop yourself on mute, I'll play your video and we'll get cracking.
Cool.
What up, right the hand here, talking history of air pressure and where it came from.
Let me just ramp that up a bit.
What up, right the hand here, talking the history of air pressure and where it came from and how they faked it, or the amount, so to speak. So in the early 1600-ish, the common acceptance was that air had no weight. Weight was what you could feel, the gravitas, the heft of something. And since we couldn't feel air, we didn't think it had any weight, or we didn't assign weight to it. So if we look at the definition of weight, it even has downward force in it. So since air does not get pulled down, since we don't witness it getting pulled down, they said that air had no weight. But they had intentions of instituting gravity, so they were laying the foundation, because this all came about when Newton was born, so they were building him up so he can have his big discovery. So to give air weight when you couldn't weigh it, they had to somehow pull off a parlor trick. Now remember, none of this magic trick will contain air pressure. It'll be water. So step one of the parlor trick is to take a basin of water. Then you're going to take the tank that you've closed off and put it in the water. Then you're going to pull the bottom plug and you're going to see how much water is still left in the tube. Based on the amount of water left in the tube, they determined that is how much air is pushing down on the water to keep any more water from coming in. It couldn't be the pressure of the water itself keeping new water from being introduced in the apparatus that they've created. It couldn't be the pulling or suction force of the lower than atmospheric pressure zone they've created inside of the barometer, quote unquote. They didn't create a vacuum inside of that barometer because water boils in a vacuum, so it's just lower pressure. That's all it is. It's lower than atmospheric pressure. It's not 14 pounds of force keeping the water down. They've just created a suction force and then applied how much water is left in that barometer to air pushing down. Now the fundamental problem with this is that you've never measured air pressure. You've measured water in this apparatus and determined through the assumption of an observation of effect that the air must be pushing down and there can't be any other reason. Not a suction force created by the pulling of the lower than atmospheric pressure. It must be 14.7 pounds of pressure. So since you can't measure air pressure, they measure the water pressure. So how do you measure air pressure? You would have to bring an area of space down to a perfect vacuum, perfect, then measure that pressure. That gives rise to two fundamental problems. First and foremost, we have never been able to remove all of the matter from an area and create zero pressure. So we don't know what the baseline for zero is. We have never reached it, we've never seen it, we've never measured it, so we don't have a for air pressure at zero to count up to 14.7 psi. The second, and tied into that, is any gauge you make won't be calibrated perfectly until
you get it down to a perfect vacuum, which we never made. So every gauge you make is based off of what? The barometer trick. Because you can't make a true barometer unless you know when you're at absolute zero, and you won't know when you're at absolute zero without a true barometer. That's the circular logic of it. How do you know when you're at perfect zero without the barometer, but you need the barometer to tell when you're at perfect zero? The problem also with pounds per square inch is that it's not like temperature. So temperature is the same in that they've never reached zero. They've just applied a number to an energy state and said that's room temperature and then have gone from there. There's other things, but they've never achieved zero, so they don't know where to start. But that's kind of okay because temperature is its own thing and doesn't correlate. With pounds per square inch and pressure, we have other forms of weight. So this reading is not just a measurement. It has a weight value applied to it, which has other values, such as the weight of a coin or the weight of lead. And if it's exerting a force, pressure is weight applied to a scale. So you either have to say weight is downward force, gravity, or weight is pressure applied to a scale, and solid weights and air pressure weights are both the same, a measure of pressure. That being the case, where and when did they take a measurement of the air applying 14 pounds of force to a scale? All right, here we have George Hanukkah, and he's going to try and explain pressure and its ability to inflate a balloon for us. So let's listen in.
Is ambient temperature. The pressure is not going to increase until this thing inflates. So what's going to happen is as I add gas molecules, the pressure is going to remain constant at atmospheric pressure. And then once we reach the fully inflatable size of the balloon, the pressure will start increasing.
My question for Mr. Hanrick would be, if you're going to inflate that balloon, that means you're going to accelerate the sides of the balloon away from itself until it's inflated. So what force is going to accelerate those sides away from each other if you're not changing the pressure, so you'll have a net force of zero? If there's a net force change of zero, then you have no force to expand the balloon. My contention is that you're taking uncompressed atmosphere and compressing it into the balloon, and the pressure is increasing as it inflates. My other issue is with how much PSI it would take for him to inflate this balloon. Let's try and figure out how much pressure he had to overcome to inflate this balloon. So if you have 14.7 PSI on every square inch of the surface area of that balloon, we have to find out the surface area. So we'll say it's a 2-foot diameter balloon. Diameter, to find the surface area of a circle, pi r squared. The radius is 1, pi 3.14 times 1 is 3.14 square feet. To translate square feet to square inches, times it by 144, because there's 144 square inches in a square foot. Then you're going to take that and multiply it by 14.7 pounds per square inch. And that comes out to 6,644 pounds of pressure on each side of the balloon, collapsing it in and not allowing it to expand. 12,000 pounds of total pressure he needs to overcome to blow that thing up. So mathematically it doesn't work out that he's overcoming that much weight. You couldn't lift that much weight with him blowing up a balloon and pushing it out. So he's not overcoming that. He is just taking the uncompressed air and compressing it into the balloon. This was all based on the assumption that vacuums do not suck or pull because they don't have a pulling force with bouncing atoms. When atoms are bouncing off of each other and off of anything, they can only push. They cannot make a pull. If you think about air as a taffy-like rope that you twist and it just gets tighter and tighter, but you'll never pull all of it out, and you can also push more and more into it and it gets tighter and tighter, that fits with what you can do with air better than if it was just molecules bouncing around, individual particles bouncing around. Now, if we are to believe that there is no suction force or pulling force of air by its nature, then you would believe that suction cups in a vacuum will not be able to work because there's no atmosphere pushing against them to keep them clinging to the wall, and there's no mechanical operation that will allow rubber to stick to plexiglass. But here we can clearly see very cheap, not professional grade suction cups adhering to the glass because of the sucking force of the vacuum inside of the suction cup is stronger than the pulling force outside of it. There is no pushing force because they've pulled almost all of the air out, which would contain the bouncing atoms which create the pushing force. And you would also have to assume in their model that inside the vacuum of the suction cup and the plexiglass, that smaller one, there is nothing but bouncing atoms there. So there is nothing but atoms pushing the suction cup away from the plexiglass, and there's nothing behind the suction cup to keep it there. So there must be a pulling force or a suction force created by the removal of air from atmospheric equilibrium. So we have no quantified measurement of air on a scale pushing at 14.7 psi. We have the weight of the water. We have the fact that all pressure gauges have never met the zero requirement in order to be counted up to 14.7 to measure the atmosphere at 14.7. We have the inconsistent measurements of needing 12,000 pounds of force to inflate a balloon. We have a lack of explanation for the pulling force of a vacuum and the lack of proof or understanding in that if you were trying to remove bouncing balls from a room, you could eventually get them all. But if you were trying to twist some sort of elastic material that was stuck to the surfaces of the container, you would never remove it all. So even in just the realm of explanation, the atomic model with bouncing 14.7 psi of air pressure doesn't make sense. In experiments in reality, it doesn't make sense, and it's not observable whatsoever empirically.
Okie dokie. Right. Let's see. Right the hand, are you there?
Yeah.
Okay, so that was a pretty brief summary. That was a 12-minute presentation there.
Yeah, I don't like to ramble, man. Like, say your piece and get out.
Very concise. It seems though that there's quite a lot of detractors in the actual chat. I mean, I know you've been keeping an eye on that.
Yeah.
Is there anybody specific? I might try something a little bit different actually, because I know that your brain works very quickly. So what we'll say is there anything you want to address in the chat right now?
Yeah, well, to anyone listening, okay, if you're going to tell me that there's 14.7 psi of air pressure, show me you measuring it at that, not you creating a barometer and then saying, oh, it must be this pressure, then we're going to set the barometer at 14.7, because you're artificially creating a zero and then making that zero 14.7. So that's my big issue with everybody who's saying, well, I'm not arguing that there's no air pressure. Okay, clearly we're breathing something. So my argument is, one, the mechanism in which they tell us air operates bouncing atoms is wrong because it doesn't explain things properly. And two, I don't believe it's at 14.7 psi of pressure because you can't measure that. You cannot measure air pressure unless because if you start at just Earth, you won't find a vacuum that you can just walk up to this vacuum and be like, okay, well, that's zero. Let's put our gauge in there. Okay, the gauge is zero. We'll bring the gauge out of the vacuum. Look at what it says in atmosphere. Oh, it says 14.7. Okay, that's what we're walking around in. You can't do that. So they have to create the zero or make the zero 14.7, and they do that with that water trick. And that's it. That's my big point. If anybody in the chat wants to address that point, I'll be glad to work on that, because that's the start. That's where this ball starts rolling. We don't need to discuss anything else until we say, can we verify this 14.7?
Okay, so the rumpus seems to, not be your best friend. He says, RightThe Hand needs about 5 years of high school education. He doesn't understand that his calc about the balloon. There is also pressure of 1 atmos in the balloon, even when he deflated it.
Okay, so what I would say to that is have old Georgie Porgy put his mouth on that balloon, right, on his little apparatus, and start inhaling. He will deflate the balloon completely. And then if you pinched off the tube, there's a vacuum in there, right? Okay, so now if he puts his mouth back on it, there is 0 pressure or less than atmospheric pressure inside the balloon. So he should now have to overcome 14.7 square inches, 14.7 pounds per square inch to inflate that balloon. But he doesn't. He just gently blows some air back into the balloon and it starts to inflate. So to the rumpus, if I inhale with my mouth attached to that apparatus and suck all of the air out of the balloon so it deflates, then what?
So Sean Hawkins, now I've never spoken to Sean, but I know he can debate. So he says, you don't know how atmospheric pressure works.
And there we go. It's we don't understand drink. So I didn't ask for somebody to tell me that I don't understand. I've had literally 100 people tell me I don't understand, but not one of them can show me 14.7 pounds of air pressure in the atmosphere just there. They can only, because here's the thing, if you can't see air pressure, which you can't because air is clear, you can't see it change. So another point I make is if you have a barometer, you're only looking at the expansion of the liquid. So you're going to say the liquid expanded, therefore the air pressure changed. Well, if things expand and contract with temperature, maybe the atmosphere is expanding and contracting, and there's not a pressure change. It's just the expansion and contraction of the fluid that is air.
So I've just asked Sean Hawkins, because he has asked me several times about this, but I've asked him, does he want to join the debate? Because he wanted to debate it. So I'd be interested to know whether.
Yeah, sure.
Now he is the equivalent. He's similar to the rumpus.
Oh boy.
Yeah, similar.
Okay.
But we'll see whether or not he wants to actually join.
Yeah, I'll do my best. I'm gonna. I'll give him the floor for the most of the time.
One thing that I have noticed is that since you mentioned. It was probably about 2 weeks ago that when somebody says they don't understand, when the Globers turn around and say you don't understand, quite honestly, I'd never thought about it before. I'd never heard it before. Well, I probably heard it, but never thought about it. But since then, I must have heard it 200 times. It just seems you don't understand.
Bro,
you don't understand.
That's why I'm like, I'm trying to make because here's like I said, you have to make, and we even spoke about this before the show, how just giving them let them talk, So if we just let them talk, and eventually the only thing they can say is, well, but you don't understand, and we just, we're snickering like, look, I bet she's going to say we don't understand. And then he says it, they won't be able to say it. It's like the rap battle with Eminem, he's like, here, go tell these people something else you don't know about me. So, okay, we know you're going to say we don't understand, but can you do more than that? So let's make it a meme. That was my whole intention, is to just laugh at them because that's all they do.
Right, so this is a question for you, so specifically from Glean. So if you have a polished metal brick or sheet and put it on a polished metal workbench, you will not be able to lift it vertically as you remove the air gap. Did RTH know this?
Oh yeah, man. So you can get. I've had metal. I used to work in the elevator division, and you can get metal stuck together. Yeah, it creates. It's a suction. You have to overcome. So what are you overcoming? And that's a good point, because if you have, let's say, two things fused together with a air pocket in there, and you're trying to pull them apart, you're not. Come on, are we really supposed to think we're fighting the outside air pressure that I can just wave my hand around? We're not supposed to think that the force that's holding these things together comes from the inside. That's just an illogical thing to think of. So that I think that two metals fused together, like two plates, I'm sure we've all had that happen. A bowl falls into a bowl and you can't get it out. That force is not the outside air pushing in. There is something inside pulling down. And that's it's part of this, I believe, is that since a vacuum works exponential, and when they get into outer space, it works in exponential, and it would just crush. If we knew like what 0.00000 to the millionth whatever power, if we knew what that kind of vacuum would suck with the force, it would destroy their model. So yeah, I think that's another part of the reason why they had to invent this, this gradient. And also a vacuum is just, it's just not 14.7. It would be like nothing, when in fact it's a monumental force. Like, they've put ping pong balls through soda cans with a vacuum. They just pull a vacuum on the tube, and just you could say the air rushing in, but no, it's that pulling force. It pulls that ball out. That's what I believe.
Something that you mentioned before, so I will read out this comment because I think it's pertinent to the point. This guy thinks an empty balloon is holding a vacuum. ... Case dismissed.
Oh, see, that's the kind of you don't understand. Well, all right, whoever said that, tell me what the PSI is inside the vacuum, inside the balloon that I've made wrinkle up almost into a shriveled raisin by inhaling and then closing the straw, inhaling and closing the straw. You know what I mean? What would be the PSI inside of that? What are they going to tell me? Oh, it's like 14.1? Get out of here. There is it's like the inner tube. A balloon works in the same respect as an inner tube. And so one of the things that I think is getting kind of lost here is when you pressurize a balloon or a tire, it's almost as if you're testing the pressure of the object. You get what I'm saying? It's like you're applying this pressure, and it's the container that you're testing, not the air. If that makes any sense, because that's where that's where your measurement is going to come from, is how much force is being pushed up against that container, and the stronger that container, the more force it can withhold, so the higher reading. So you never really measure air pressure. You measure physical matter, solid matter's ability to withstand something, and they assume that something's air pressure.
So from Sean Hawkins, RightThe Hand will have to demonstrate a greater maturity than he has so far. Also, dome research wouldn't hurt him, so I think that means do some research wouldn't hurt him. So again, the rumpus, it's that same thing you don't understand, but he said it in a different way this time. Does RightThe Hand realise that vacuum pumps have to be powerful to make any remotely low vacuum? RTH is willfully ignorant.
So, okay, to talk on a vacuum, let's just, let's think about this. If you had a space and you had a vacuum pump on it, and you're pulling a vacuum, and there's just bouncing atoms, right? Eventually, you'd get them all. Like if you've got a ball pit and you got all these atoms bouncing around, all these balls, these little atoms bouncing around and causing collisions, and you're sucking them out, you would get them all out eventually. And even then, if you didn't get them all out, the ones that would left would settle to the floor, right? Like, so even if we think about this logically, the atomic model doesn't make sense. Now, if you think about air as like a rope-like material, and the vacuum pump is twisting it and creating, because they say light moves in a wave, but I think it's just moving through air, which is a wave, which is a rope-like, and it moves through that pattern. So the rope that it's moving through will get tighter, and you'll get a shorter frequency, but you'll never be able to pull it all out, because it snaps back with like an elastic force almost. And again, that just, you can't prove either one of those, right? Because we can't see what's going on at that level. But one makes sense, the other is, debatable. And this is where, like, again, I brought him up a couple times. I think everybody should check him out, even though he doesn't believe in God and he thinks the Earth is a ball. But Bill Gates has this great explanation that it's so much better than the atomic model. And I'm like, look, if we're just going on, models, his is so much better. Like, they talk about, well, we've modeled it, and okay, well, your model sucks compared to his. It explains everything so much better.
Okay, so we had a question. Just let me find it now. He can measure a tyre pressure, 33 PSI, and one flat tyre. And when you connect it, the final pressure will be half. Then why is air pressure 14.7 PSI at sea level? Don't go to 1 mile. I don't understand the question, to be fair.
Yeah, I mean, I'm trying to find it here. I didn't really.
Hugo
Well, he's
Perez.
saying, all right. So I think one of the here we go. He can measure tire pressure at 33 psi on one flat tire, and when you connect it to the final pressure, it will be half. So the thing is, you can measure. Yes, we can measure pressure in a container, right? Like in a tire, we could say, oh, this is at 33 psi. But this is where the trick comes from. That original measurement comes from the amount of water weight. We never measured air pressure. We measured the amount of water that the siphon barometer, aka that they use, needed to equalize. So you're never measuring 14.7. So we don't know what a tire pressure is. And this is another big point that I make. Like, you can't count to 10 unless you know what 0 is. And if we're going to say that 0 is no atoms whatsoever, but we've never had that, then how do we know we're at 14.7? We don't even know what 0 is. What if something drastic changes, with the way it scales, so it would scale up to 5 pounds with new math at a pure vacuum. This is why it's just, these are just numbers. And it would be okay if it was temperature, but because it's dealing with weight, which has another connection to the real world, it makes no sense.
Okay, so from Saucy London, question, what is the air pressure inside an empty cup?
Yeah, that's so I think there's no force exerted. So I think air, when you're standing in it, exerts no force. Not that there's no pressure, it's exerting no force. So once you take the air and you put it into a container, it is now exerting force and stressing the walls of the container, and that's what will give you your pressure reading. So you cannot, and this is where it comes down, you'll never measure atmospheric pressure, because the only way to measure air pressure is to put it into some kind of container. And then once you've contained the air, it is now not atmosphere anymore. So, and this is, I made a short video about it's a logical fallacy. You're saying, if I can compress air, then the atmosphere is compressed air. I can compress the atmosphere is compressed air. That doesn't work like that. So what if the atmosphere was an uncompressed gas, a free expanded gas sitting on top of Earth with no, nothing holding it there? It's just almost ethereal in its nature.
Okay, so I know that you're always up for a debate, so if anybody wants to jump on in and challenge RightThe Hand on this pressure idea, or anything to do with pressure, let me know and I'll jump you in. But in the meantime, let's look for some other questions. We've got from the Rumpus saying, I am making a fool of myself to allow someone this stupid onto my Hangout. Well,
I mean, look at this from Sean. You have no idea what it takes to create a perfect vacuum, from Sean Hawkins. Either do you, because you never created one. So, and again, that's a remalformed, you don't understand. You have no idea means you don't know what it takes to create a perfect vacuum. You don't understand what it takes to create a perfect vacuum. Thank you, Sean Hawkins, for saying I don't understand. Yeah. George Hanukit saying the same thing.
There seems to be a lot of that going around. And I know that George was good enough to come on before and do his presentation, and you jumped in there. I mean, what was the conclusion for that for you? How did you see that back and forth went?
I to be honest, I think he's in denial. Like, he's in denial that he has more than just the equations. Like, I could get the equations from interacting with reality. Like, if you gave me 100 years, 1,000 notebooks, I could figure out lunar eclipses and give me a huge telescope. Like, if I just observe the world, you know what I mean? That's what they're doing. They're observing the world. Drop a rock, float a balloon, launch a rocket. They're just observing the world and then taking notes. And then at the end of the day, they have this encyclopedia on how things behave, and they think with that they can make up a story that explains why. And I think that was George's biggest problem, that he wouldn't accept that he didn't have more than just what we observe in reality and the quantification of it. And that doesn't prove atoms, that doesn't prove the sun is helium, and then of course he'll get it, well, we did 1,000 other experiments. Yeah, but those, that's where you get into like the magic trick of it and all. It's, if it was what it was, you would just prove it in reality. If mass attracted mass, I wouldn't need to set up this torsion bar with things dangling off the side of it and make sure my grandma doesn't, come walking in because she's going to disturb it. Like that's not what the nature of reality is like. It should be easy, it should be simple, and it should make sense. And if you gotta, construct an apparatus to prove your point, like, your point is not proven.
So I can see there's at least three interesting questions. So the first one would be, does RightThe Hand think the air pressure housekeeping question on Nathan Oakley's channel is legitimate?
I saw that from Matthew Stevenson. I wanted to address that, so good grab. So I don't, because I think it falls into that logical fallacy. I think you're saying we can compress air, therefore the atmosphere is compressed air. So that you're totally closing off the door of a freely expanded gas that, because we have to, you can't say that X amount of gas, right? You have a set amount of gas. Now, if you start changing the volume, add to anything, that gas, that amount of matter will fill that amount of space. That's impossible, because now, what if I have 5 atoms? 5 atoms in an Earth-sized container. Is that filling the space? What is going on? How fast are these atoms bouncing around that they can, are they going from one side of the Earth and the other? What if it leaves? Are you getting a zero pressure measurement, and then when the atom hits, you get a super high measurement? That's another thing. That doesn't make any sense. If we have these atoms colliding, why is the pressure so stable, right? Why do we get such a constant reading if it's these random bouncing particles? It would always be sputtering. It doesn't make sense. And, again, to quote Bill Gaty, the explanation is what I can give you. Now, belief and proof, that's a personal thing, right? What you believe, that's personal. What you can prove, that's personal. I can't do anything. I can only explain it and see if it makes sense. And their explanation doesn't make sense.
Okay, so I'm getting a couple of conversations going in Skype. So it looks to me as if the Rumpus wants in for sure. It might be George Netanyahu who wants to rejoin, I think. Let me just recheck. But in the meantime, could you answer this question from Rock Farmer? What would mainstream science have to do to explain better so we can get beyond the you just don't understand? What would be acceptable?
All right, so again, not to plug the dude again, Bill Gaty, I like his explanation better. So first, if you want to go on pure explanations, go with that. 2, explanations don't prove anything. Like I've said this 1,000 times, I can explain how I make a unicorn. Horse DNA, Norwhale DNA, splice it up, add some frog, you got a unicorn. Like that's, that makes sense, it's feasible, but it didn't prove a unicorn. So like when it comes to what does mainstream science need to do to prove air pressure at 14.7, I don't think it can, because I think it's an erroneous claim, much like saying that the Earth's mass pulls everything down, but we can never test it because we're living in this huge gravitational field. It's one of those things, we can't test it because it is almost.
Okay, so are you happy to have a chat with both George and the Rumpus if they joined the call?
Yeah, sure, bring them on in.
Okie dokie. So bring in George. I'm bringing the Rumpus. This should be interesting.
I'll do my best.
I would highly recommend for the audience to turn the dirt.
Lower the volume.
Lower the volume, because this could get insane.
No, look, my mission's to play. That's on them. But I'm gonna try and I have one argument. I'm gonna stick to it, because I don't think they can answer it. So.
Okay.
But who knows what I'll do? I'm human.
So the Rumpus has joined, so I believe, and so has George.
Yeah, I'm here.
What up, everybody?
God, you're stupid. I mean, it's just unbelievable. When you did that calculation about the balloon, and you said that George had to overcome whatever it was, how many pounds of pressure, what you don't understand, because you don't understand anything, is that inside George's lungs, there is a pressure of 14.7. So when he adds extra pressure by compressing his lungs, he's already got the 14.7 psi. There's already in the empty balloon, there's 14.7 psi, and there's outside the balloon of 14. So the only thing he has to provide is a differential, an excess of 14.7 psi. And he does that by compressing his lungs, and that generates a little bit of an excess, and then that inflates the balloon. The fact that you don't understand this simple thing that 13-year-olds understand is a horrible indictment of what your school teacher did, assuming you ever went to school, because the stupidity you've been advocating is just extraordinary.
Very well put, Rumpus.
Okay, so then could either of you demonstrate 14.7 pounds of pressure being measured in the atmosphere?
Yeah,
sure.
Android.
Yeah, all we have to do is get a vacuum bell jar and put a plunger to it, through it to a little scale at the bottom, and then make your plunger 1 square inch in cross-sectional area, and then just have it go through some sort of a sleeve in your bell jar so that it can freely move down, and evacuate the bell jar, and you'll find that the weight scale at the bottom will increase and eventually reach 14.7 pounds once you fully evacuate the bell jar.
Okay, so let me ask you this. Did you measure the air or the rubber and a force applied to it?
Rubber.
Okay, so you never measured air
pressure.
No,
I'm asking you. That's a question. Rubber. What rubber are we talking about?
You said you put a rubber thing in a tube.
No, I didn't say that. I said you put a scale at the bottom of a bell jar that you can evacuate, and then you have a plunger, some sort of a stick with...
What's a plunger?
A plunger is like a rod
with a rubber on it, right? That gets pulled down?
No, you don't need a rubber on it.
Okay, so what is it sealing to the outside, or has it sealed?
Yeah, you have to seal it to the outside.
Okay, so and the plunger hits the scale?
Correct.
So you're measuring the plunger, right?
No, you zero it out. You can tear away.
Okay, but wait, what touched the scale? Air or the plunger?
The plunger.
So what are you measuring?
You're measuring the air pressure on the stick pushing down.
How do you know that? How do you know you're not measuring the stick?
You can tear it out. All you have to do is put 2 bell jars. Put 1 bell jar in front of put your scale in a bell jar with the plunger, and then I'll put a bell jar on over that whole assembly. Evacuate both, tear away your plunger or your scale so it reads 0, and then let the pressure go inside, or let the air inside the outside bell jar, and you'll see that the weight will increase.
The plunger. The plunger. So you're measuring
we already teared it out. I say you tear it out. You know what tear weight means. You zero it out.
Okay, where did you... Okay, so your scale. Okay, so let's... Before we get any further. So we have this scale. Okay, hold on. So we have this scale. Now, the scale... The air is always applying 14.7 psi to the scale, right?
No.
No?
You evacuate the jar.
No. Before the... So, but the scale, before you put it into the vacuum, you're not programming it in the vacuum, right? It's been calibrated already.
Yes,
wait, hold on.
You tear. That's what I said. You put it in the bell jar. You evacuate the bell jar, and you tear weight the scale to read 0.
And do you understand that yes, and you measure the force that a plunger applies?
No, he's zeroing it.
Yeah,
he's
but
zeroing it in the bell jar in a vacuum. Jesus
and then what
Christ,
pushes
you're
on,
stupid.
What pushes on the scale? Does a plunger push on the scale, George?
The weight of the plunger does, and you zero. Zero it out.
But you're not measuring air. Again, it doesn't matter if you zeroed. It doesn't matter if you zeroed it out. You're measuring the plunger. You're measuring a physical object. You're measuring the physical object, which is the plunger, not the air pressure.
You're set to 0.
Your assumption.
When the plunger is on it, he sets it to 0. Then he introduces the air pressure, and that causes the additional force over and above.
No, that's what you think.
No,
that's your assumption.
He's doing. You don't understand what he's explaining then.
Okay, no, I do understand.
No, you don't understand, because if you did, you wouldn't have said that stupid thing you just did.
Okay, so I'm going to explain for the audience. He has a scale, he has a vacuum, and he has a plunger. He pulls a vacuum. The plunger moves onto the scale and applies a force.
And then he zeroes it, you moron.
And then he zeros it.
Right, so he's accounted for the plunger.
And then he removes more air.
Still don't have it. I'll draw
let me finish.
diagram.
Guys,
in front of the camera. I'll draw a diagram. I'll put it in the
we don't need a diagram.
You do need a diagram because you don't understand.
Okay, we don't understand. Drink.
You don't understand. He's having to draw a diagram for you.
Okay, so he puts the plunger onto the scale, pulls a vacuum, gets a reading, then zeroes it out. Right?
No, that's not what I said. Just
okay, George. No, I don't need the diagram.
Yes, you do, because you don't have it. You have two bell jars.
George, no, this is a yes or no question. Is at any point the scale getting a reading without the plunger pushing on it?
Okay. Can you see?
That was a question I just asked.
No,
George.
Rumpus, look at this. Rumpus, look at this and tell me.
Please answer the question, George. Can you answer the question I asked? At any point,
I'm
does
not
the
going to
scale?
Answer until you look at
okay, but then why are you here? Why are you here if you're not going to answer the question?
He's going to explain to you, not deal with your imaginary problem.
Why?
Give me 30 seconds. I'll explain it. Give me 30 seconds. Give me 30 seconds.
I need you to answer this question.
He designed this, right? The hand, not you.
Okay. I'm not looking at the screen.
Not you. He will explain it, and then you can quiz it.
No. He explained it. I get it.
He hasn't explained
it yet. You don't have it.
Explained it twice. Now. So
there's two bell jars.
Let him explain.
George, Rumpus, let George talk.
He wants to explain his experiment.
No, he doesn't.
He wants to explain his experiment.
Okay, so George,
he wants to explain his experiment.
Rumpus, you're just repeating yourself. So
there's no point in you invalidating an experiment he's not offering. He'll explain his experiment, and then you can criticize it.
Okay, he already explained it. So you have a plunger. He did. He explained it 3 times.
He has not.
So you have a plunger.
Let him explain his experiment.
He did. He has a plunger that's in the vacuum and it's
little wanker. Let him explain his experiment. Let him explain
a plunger in a vacuum.
Experiment. Let him explain his experiment.
He doesn't want me to because he knows it's going to destroy.
You're going to let this wanker stop George explaining his own experiment.
Rumpus is interrupting.
Okay, here's the experiment.
Francie, can you stop this guy censoring George?
Just give me 30 seconds and I'll explain the experiment. We have 2 bell jars. Can you see it? I
told you I'm on Skype. That's why I'm trying to talk to you. I can't see the YouTube.
I have a scale here. I'm explaining it to Ranty, and then Ranty can explain it to you. I've got a scale here. I've got a plunger going through. I have a bell jar here that can be evacuated. I have a plunger going up through the bell jar, and now I have another jar surrounding the first jar and the plunger. So the first thing we do, we evacuate the inner jar, we evacuate the outer jar so that there is no pressure inside. We zero tear the scale. So the weight of the plunger is zeroed out on the scale. Now we keep the vacuum in the inner jar, and now we let atmospheric pressure come in on the outer jar. So the pressure, outside pressure, is pushing on down on the stick, and that's what it will register on.
Okay, so I did understand it. So you measured. So on the scale, it measured how much the bar or the physical rod was pushing.
Correct.
Yes, I was right.
No, and then
we zero it out. We zeroed out before we let the air in the outside.
No. You gave me. I gave you 30 seconds. You have to give me the same respect, George. And Rumpus, you have to give me the same respect.
Okay, that's fine. I accept that.
You're just give it to me. Don't talk over my 30 seconds. You don't talk. Just give it to me. I can waste my time if I want to. I only need fucking 10. I'm not like you. I don't need 60. My point was, in 4 seconds, you only measured the force of the bar pushing the scale, not air pressure.
He zeroed it, you twat.
No, we zeroed it out,
hold on.
We let pressure in on the
understand
outside.
this. Okay. How can you not understand that he zeroed it?
How do you not understand
twat?
How do you not understand that the only thing that is physically touching the scale is the bar? So the only thing
zeroed that. He eliminated that weight
Rumpus,
by
even
zeroing
if we didn't zero it, even if we didn't zero it,
even if
we didn't zero it,
your
what
assumption,
the scale would be reading is
the reading
weight
of the scale
plus the additional pressure.
No, there could be another reason why. Let me finish. There could be another reason why the scale, why the rod pushes down with a harder force. Now, your assumption is air pressure. That's your assumption, okay? Now, you can't prove that. You can just assume that. But what you have in physical reality is the bar pushing the scale. Now you could say, but we vacuumed it
what
out.
about
Great.
the
Hold on,
additional
let me finish. Let me
twat.
finish.
What did the bar do, bro?
Jesus
Interrupt.
Christ.
Does the bar
So he's
grow
gonna-
when they
they're-
look at
they're
the
gonna
area?
You
interrupt.
keep on
They're
making the same
interrupt.
point, you twat, and we keep on telling it's like having a measuring
Okay.
scale,
There we
and
go.
you change. It's like putting something like when, for instance, when you put some grapes in a weighing device, and then you zero your little scale such that it shows 0, you've eliminated the weight of the grapes.
But you're
similarly,
assuming the force.
hold on.
You're
Similarly
assuming
with
the
this
force.
bar, he zeros it to eliminate the weight
and
of
then
the
assume the
bar.
force.
Hey,
And then
Rumpus,
assumes
even
the
if
force
we
is air
didn't
pressure.
zero it, even if we
And then
didn't
assume the
zero
force is
it,
air
the
pressure.
scale would read
show difference.
the weight of the bar.
But it doesn't matter. You're measuring the weight
Yeah,
of
so
the
it would show the
bar and a
difference. Yeah, I
force.
agree with you,
You're
George, yeah.
measuring the. Hold, stop. You're measuring the. George, give me this. Yes or no? Are you measuring the weight? Are you measuring the weight of the bar and the force? Yes or
No,
no?
because you've zeroed it.
Okay,
well,
so
we don't have.
No, hold
Okay,
on,
even-
George.
Hey,
Do you agree
yes,
that? Hold on, do
you
you
don't
wait,
even
wait,
have to
wait,
zero
wait.
Initially,
Do you agree? Let me,
wait,
George.
before I
George,
let-
do you
before I
agree
let
that
the air
George,
in,
George,
I'm telling
George,
you,
stop.
Jesus.
Do you agree with Rumpus that with what he said?
You've zeroed the scale, so effectively you're not measuring the weight of the bar.
I didn't. No.
Just
so
like
I said,
when you have
George.
grapes and
George.
just like when you have
Rumpus.
scale,
I didn't ask you.
Rumpus is
Rumpus, I
correct.
didn't ask you.
and you
Rumpus.
zero it, you've put a 0 for the weight of the grapes. And as
George,
George said, you don't need to zero it because you can see the difference
Hey,
anyway.
Rumpus.
George,
Rumpus,
do you-
we can get over this hurdle. We don't
Okay,
even
George,
care.
give me
Let's
10
not even
seconds.
care
George, give me
weight.
10 seconds. George, give me 10 seconds. Do you agree that you are measuring the bar and a force that is making it apply pressure to the scale? Yes or no?
Both. Yes.
So,
weight of
okay,
the
so
bar
wait,
plus an additional force that's
You
on
I
said
didn't
the
ask
want
for your
10
fucking
seconds. You had 10
monologue.
seconds.
Hang
No,
on, I have to take charge here, and it's
come on, man!
It's
I
a simple
can't.
yes or no
Bro,
question.
this is ridiculous.
It's a simple yes or no question. So there was a simple yes or no question.
Fucking God,
answered,
man.
Answered by George. Now it should carry on, right the hand. Carry on.
Okay.
Okay.
Now George's turn, Ranty.
No,
he answered the question. Then it was a leading into
Yeah, now
another
it's George's
question.
turn.
No, it was leading into another question.
So I asked, were you measuring the bar and a force that is applying pressure to it, and or a force being applied to it? And Rumpus said no. Now,
You
George,
zeroed it. You
oh my
eliminated it.
God, can you stop interrupting? If you interrupt one more, I gotta leave because I got
Go,
better shit to
fuck
do.
off, you wanker. You really are the most odious twat. That guy is the worst, Ranty. The fact you let this guy come on is just shameful. And this is the guy who abused Brenda as well, and claimed he was, she was.
Right. Well, that was that. Well, I hope you all enjoyed that. Anyway, I'm going to spam the link for IRM. There we go. That's the link for IM Realm Media. So they should be starting any minute now. In the meantime, that didn't go entirely to plan. But I do hope to be doing back tomorrow with the Aftermath show, and then I will be spending an hour or so doing a presentation of my own around about 11 PM BST, that's London time, tomorrow, and that will be specifically on optics and all the effects going on at the horizon over water. So with that, I'll see you all in the next one, and everybody for stopping by, thank you very much.